Welcome to Engineering Physics. My name is Dylan Gunn. I'm the director of the project lab in the Engineering Physics program. That's the dedicated lab where our students do their capstone projects in their senior years. So let's talk a bit about engineering physics. What is engineering physics? So it's a long-standing, fully accredited engineering program at UBC. It is a 5-year degree with a very strong core foundation in mathematics and physics, and we have that strong foundation to really prepare students to work in new and emerging industries. What programs or options are available in engineering physics? Well, we have the very strong core, and that actually includes courses in all of the major engineering disciplines. So as an engineering physics student, you would take courses in mechanical engineering, in electrical engineering, in computer engineering, computer science, materials. So you get a really strong core that includes elements of all of the major engineering programs. And then in addition to that, you would be taking a lot of math and physics. So there's a very strong kind of common core for all students. And then beyond that, students have a lot of flexibility in choosing their technical electives. Some students choose to focus in one area like electrical engineering, and they can declare a subspecialization in electrical engineering, and it would include that specialization on their degree, or they might use it to explore a whole range of topics. Maybe they would do some electrical engineering and computer science, or maybe they would do astrophysics and biophysics. So there's a lot of flexibility to the degree in combination with the very strong core of fundamentals. Just one point here, because it is such a highly sought after program, we do have special requirements to entry. So in addition to the regular application process that you would go through at the end of your first year of engineering to get into any subspecialization, we also have an interview process where we interview every student. So please keep an eye out for that if you are interested in applying for the program. What can you expect to do in your degree? Well, we have a very heavy focus on hands-on project-based learning. You will take 4 project-based courses in your degree, one in every year, in second year, third year, fourth year, and fifth year. So in second year, in a team, you will build a fully autonomous robot from scratch. So that means all of the mechanical fabrication, electrical circuits, analog and digital circuits, writing the code, the control software, everything. In your third year, you do a project course in applied reinforcement learning, and we really believe that every student should be graduating in this age with some exposure to machine learning and artificial intelligence. And then in your fourth and fifth years, you do 2 8-month capstone project courses. So I think all engineering programs now have a capstone project course, whereas in EngPhys, we have basically 2 full years of capstone to really lock in your practical and applied skills. You also have access to really exceptional resources. I think at the top of this list is the project lab. Since 1978, we've had a dedicated lab for engineering physics students, lab and workspace. So that's filled with all kinds of tools. You have access to our machine shop, a water jet cutter, laser cutter, 3D printers, all kinds of hand and power tools, workspaces, power supplies, test and measurement equipment, all kinds of stuff. And what's really special about this lab is it employs 3 full-time staff of professional engineers. And our job is just to work with you basically 100% of the time on your capstone project. So we're not doing our own research or publishing or grant writing or anything like that. We are fully dedicated to doing projects. So it's almost like you have apprenticeship-based learning with professional engineers throughout your degree. And then the program is led by Andre Marziali, who is a graduate of the program. And for those of you interested in entrepreneurship, Andre and myself and Midi actually founded and ran a successful biotech company for several years. So it's a small team that runs the program. We also place a very strong emphasis on community. Engineering physics is a very challenging degree, and so we have a mentorship program set up where we connect senior students to junior students, and that can be for all kinds of reasons. It can be just social stuff, having fun and hanging out. It can be getting good advice from senior students on what courses to take or co-op opportunities, things like that, help with homework assignments. So we really do try to build the community, and we have a very strong and tight-knit community of alumni that support the program as well. So what can you expect from your student experience? Well, there's a lot, but I'll just highlight one student here who I think did an exceptional job of really getting the most out of the program. So this is Andrew Chen, who graduated this past year. And in addition to all of the EngPhys courses, of course, he led the avionics team and the UBC aero design team. So obviously learned lots of practical skills there, firmware and controls and software and things like that. He did some really interesting capstone projects. On the right there, he did a phased array of little piezoelectric ultrasonic transducers, so little speakers, if you will, and actually built a system to levitate styrofoam beads. So very complex project with a 10-layer PCB and lots of firmware, all driven by FPGAs, lots of forward and reverse modeling of the physics. So very interesting project. And then all of this culminated when he graduated in getting a job at Neuralink. So I think this is a very good example of someone who's got that very strong training in the core math and physics and is now contributing in a brand new multidisciplinary emerging industry where everything is really being done kind of from scratch. Here's a couple other examples. So Connor Shannon on the left there graduated several years ago, and he and a classmate built this robot in their capstone project, kind of an emotion expressing robot for human computer interaction. They started a company to build robots like this right after graduating, and then they were quickly acquired by what's now a big humanoid robot company called Sanctuary, which is very prominent. They've been featured in Time magazine and lots of other prominent places. And then more recently, Kritika, who graduated a couple of years ago, she did a capstone project sponsored by Sanctuary, and she's now working as a mechanical engineer at Sanctuary. There's lots of opportunities for getting involved in research. You can do this through co-op and directed studies, and also through your capstone projects. On the top there is an example of a robotic phantom. That's sort of a simulated human torso that actually breathes, so all the organs move. And BC Cancer wanted that so that they could calibrate out the motion artifacts from people in CT scanners. So our capstone students built that, and they actually published some papers on that. And then at the bottom is a Helmholtz coil to shim and bias the magnetic fields in superconducting radio frequency cavities, which are used to accelerate particles in particle physics research. So just two examples of students getting involved in real research through the capstone projects in totally different fields that speak to the breadth of engineering physics. What is the industry demand for engineering physics, and what career options can you pursue with your degree? So the industry demand is huge. Basically, we hear from employers all the time, and because technology is accelerating so quickly and things are changing so quickly, everybody's looking to take the next step and do something new, not simply improve on what they're already doing, but figuring out how to do something new entirely. So, if it's an automotive company, it's not just trying to make a better car, it's trying to make a self-driving car, for example. So lots of demand from industry because of that fundamental skill set and the ability to innovate. And it really spans the gamut from, traditional things you would think of for engineering, like robotics, maybe, to things like biotechnology and biophysics. So there's very strong demand there. Here's a great example of a student who graduated a couple of years ago. This is Andrew. He was very interested in rocketry all the way through. He had some rocketry co-ops. He did a very interesting project in capstone where he built an AI-powered air hockey playing robot. So lots of controls, mechanical engineering, electrical, just all across the board, very multidisciplinary. And now he's working at SpaceX developing the Raptor engine, the new version of the Raptor engine. Graduate school is another common pathway. So for an undergraduate engineering program, a fairly high proportion of our students go undergraduate school, and they often go to the top schools. So we send lots of students to places like Stanford and ETH Zurich and MIT. So there's lots of examples you can read there on the right. And entrepreneurship is another common example. So we have students who start businesses right after graduating, maybe based on a capstone project, or more often, maybe they work in an industry for a few years and see what's happening at the cutting edge and what kind of problems and opportunities exist, and then start their own company. So we have everything from Carl Hansen there, who was a graduate in 2000, who started several biotech companies, and most recently launched Upcelera, which had a multi-billion-dollar IPO a couple of years ago. And then Eugene Chen on the bottom had an interesting career in finance for a few years, and then decided to start his own company where they're bringing real-world assets onto the blockchain. So just an example of the diversity that's out there. So I hope that gives you a bit of an overview of our program. Definitely look us up and reach out to us if you have any questions, and we look forward to seeing you in the interviews at the end of your first year. Thanks for watching.